Right, we have this word problem in front of us, and we shall proceed to solve this particular word problem in a step-by-step fashion. The word problem reads as follows. The sum of 4 consecutive odd integers is 72. Find the integers. Right, so we proceed to solve this problem as follows. Right, to present a solution, first, we let x be equal to the first. Right, the first odd integer, like so. So now, because these integers are odd, this obviously now we're dealing with 4 consecutive odd integers, and x is the first odd integer. Then the next one is going to be x plus 2, which becomes the second odd integer. Right. After x plus 2, then the next one is going to be x plus 4, which is the third odd integer. Right, after x plus 4, the next one is going to be x plus 6. Right, x plus 6 is going to be the fourth odd integer, like so. Right, now if this actually is just the least of the first 4 integers, so we can add them up as follows and then say hence. Right, hence the sum is going to be x plus 2 plus x plus 4 plus x plus 6 is equal to 72. Right, equals 72, like so. And then now, if we add all these, x plus x plus x plus x will give us 4x plus 2 plus 4 is actually 6 plus 6 is actually 12, and this equals 72. So if you have an equation like this, then what we're getting is 4x plus 12. Then we can subtract 12 to eliminate 12. We can subtract 12 from the left, but also 12 from the right, like so. Right, so we subtract 12 from both sides of the algebraic equation. So 12 minus 12 is 0, leaving us with 4x on the left. And on the right, you have 72 minus 12, which is a 60. And this gives us 4x. And 4x equals 60. And upon careful examination, you have you divide by 4 the left, and divide by 4 the right, and what we're then getting is actually exactly a 15 from this. X equals 15. Right. Thus, right, we have the following. Right, so thus we have the following numbers, or the following lists. Right, we have the following lists. Right, so we have the following lists. Right, so we have the following lists. What are the lists? Right, we realize that those numbers were x plus 2, x plus 4, and x plus 6. With x equals 15 that we've got, so it's going to be 15 here. You add 2, it becomes 17. You add 4, it becomes exactly 19. And you add 15, you add 6 to 15, it becomes 21. And you can do a check, right? You can do a quick check that when you find the sum of this, 15 plus 17 plus 19 plus 21, the result equals 72. And now these actually are the odd integers, but they are consecutive odd integers, okay? And they give us the sum of 72 there as required. However, there is more that we need to actually say here. So we need to include a little comment. Note that. Right, let's note down the following, or just a note. Right, what is this note here? Right, if you look at a list, right, let's look at a list of the following odd integers. Consider the list of the following odd integers. Right, we can list these odd integers, and by listing them, we have, for example, the odd integer 1, the odd integer 3, the odd integer 5, right? The odd integer 7, the odd integer 9, the odd integer 11, the odd integer 13, and so on. So now, if you then attempt to find the actual differences between these, you can realize that 3 minus 1 is a 2. 5 minus 3 is a 2. 7 minus 5 itself is a 2. And we have 9 minus 7 is 2. 11 minus 9 is 2. But 13 minus 11 is also 2. Right. What we can see here, and what we can note, is that the difference between the consecutive odd numbers is 2. Okay, that is something that you need to note here. And hence, as a consequence, what does this mean? And this actually is enough evidence to strengthen the fact that if you have that x is the first odd integer, the next one must be x plus 2, okay? And the next one becomes plus 2, and x plus 2 is a 4. And now if you have x plus 4, the next one will be plus 2, so that 4 plus 2 is a 6. Okay, and we reason is indicated here. Right. Now, for example, if 3 is the first, or let's just say 1. Right. For example, if the number 1 is the first, right, is the first odd integer, then what do we get? We get 1. And then you add 2. After that, you add another 2. You add another 2, and so on. Okay, just listing a few here. So we have 1, and 1 plus 2 is a 3. And here it's going to be 1 plus 4 is a 5. And 2 plus 2 plus 2 is 2. 4 is 6 plus 1, 7. Okay, this gives us a list of the odd integers, but these are the consecutive odd integers. And obviously, we just have generated a list of 4 of them. So in the same way that we solved this one and realized that 15, 17, 19, and 21 are just 4 integers. It's a list of 4 integers. whose sum is 72. We have solved this problem in a step-by-step fashion. Thanks everybody for your time and attention, and goodbye to you.